The engine starting system is designed to provide sufficient rotor speed to initiate combustion light-off and to obtain self-sustaining engine propulsion. The starting system includes an air turbine starter, ATS, a starter control valve, SCV, portions of the bleed air system, and starting control panel. Engine starting is a combined aircraft and FADEC operation. The FADEC controls fuel flow, the starter command, and the ignition command, while the aircraft controls the starter control valve and the engine-driven pump, EDP, of the hydraulic system, and also switches power to the ignition exciters as commanded by the FADEC. The aircraft also manages the bleed system interface during starts. By selecting the Start-Stop selector knob on the engine control panel momentarily to the start position, pressurized air is directed to the air turbine starter, which rotates the engine rotor via the accessory gearbox. The FADEC automatically commands the ignition and fuel flow on. The FADEC schedules the fuel flow to accelerate the engine to idle, de-energizes the starter control valve at approximately 50% N2, and turns the ignition off when the engine reaches idle. Note that the isolation valve is automatically controlled only if the cross-bleed switch is selected in the pushed-in auto position. For windmill start, the engine rotors are rotated by the aircraft forward airspeed, providing windmill rotation. The start is commanded through the Start-Stop selector knob, and the FADEC then automatically commands ignition and fuel. Ignition will be turned off when idle speed is reached. Note, the hydraulic engine-driven pump is unloaded by energizing the engine-driven pump solenoid during engine windmill starts in order to reduce drag on the core rotor. An assisted start sequence is carried out as follows. The ignition switch is placed in auto position. The bleed air system is then configured so that air at the starter control valve is available. The Start-Stop selector knob is momentarily selected to start so that the MAU senses the start switch closure and sends the start switch signal to the FADEC. The starter control valve opens. The FADEC commands the ignition on at approximately 6.7% N2 and the fuel metering valve to open at approximately 14% N2. The FADEC will schedule the fuel flow to accelerate the engine to idle and will de-energize the starter control valve at approximately 50% N2. Ignition will be turned off when the engine reaches idle. An in-flight assisted start is identical to an on-ground start, except that the FADEC will open the metering valve if N2 has not reached 14% after 15 seconds. A windmill start is performed according to the following sequence. The ignition switch is set to auto. The Start-Stop selector knob is momentarily set to start. The switch position is sensed by the MAU, which sends the start switch signal to the FADEC. Since no pneumatic pressure is available, the starter control valve does not open. The FADEC recognizes that the starter control valve remains closed after the open demand and automatically commands ignition at 6.7% N2 and fuel flow at a minimum of 6.9% N2, or after 15 seconds, whichever occurs first. The FADEC will schedule fuel flow to accelerate the engine and turn off ignition as idle speed is reached. The FADEC start protection logic provides automatic hot, hung, and no light-off start protection with the aircraft weight on wheels. Hot and hung start protection is inhibited in the air so that the FADEC cannot prevent an in-flight start. The hot start protection will terminate the start when internal turbine temperature rises above 740 degrees Celsius during a ground start by closing the fuel metering valve and shutting off ignition. In this case, the FADEC will not de-energize the starter driver in order to allow immediate engine cooling by motoring. To terminate motoring, the Start-Stop selector knob has to be moved to stop.